Unit 4 is still talking about trig and triangles. We are talking about today Pythagorean theorem, but we are going to get into sine, cosine, and tangent again in the later lessons. So today is hopefully a bit of a review because we've discussed and used the Pythagorean theorem a lot this year, especially in the first semester. So just to recap, Pythagorean theorem has to have a right triangle in order to use it. So a right triangle is required. Right triangle. And the Pythagorean theorem says that we have a squared plus b squared equals c squared, where c is our hypotenuse and a and b are the two legs. And a and b can be interchanged. C has to be that hypotenuse though, and the hypotenuse is always across from the 90-degree angle. Now we have something called a Pythagorean triple, and a Pythagorean triple are three positive integers. And remember, integers are positive or negative whole numbers. So they can't be a decimal, they can't be a square root that doesn't simplify into a whole number. They have to be a whole positive or negative whole numbers. So three positive or negative whole numbers, A, B, and C, that satisfy the Pythagorean theorem. So let's start with example 1. For part A, it says, are either of the two triangles shown, triangle A and triangle B, a Pythagorean triple? Justify your answer using the definition of Pythagorean triples. So our first one, A, we have to find our missing hypotenuse here. So we can do 3 squared plus 4 squared equals our x squared or c squared. So this was triangle A. So we get 9 plus 16 equals x squared. 9 plus 16 is 25. I'm going to make this a little bit thicker. So we get 25 equals x squared. And then we're going to square root to get the x by itself. And then the square root of 25 is 5. So then if we have our three numbers, the 3, the 4, and the 5, those are all positive, what does this say? So positive integers, basically whole numbers, that satisfy the Pythagorean theorem, that work with the Pythagorean theorem. So these are all positive whole numbers or whole numbers. That work with the Pythagorean triple or theorem. So yes. Same thing with triangle B. So let's see for triangle B. We are missing this leg over here, so we can say that's B. So I'm going to plug that in and do 5 squared plus b squared equals our hypotenuse, 13 squared. We get 25 plus b squared equals 169. Subtract our 25 on both sides. We get b squared equals, when we subtract, we get 144. And then we're going to square root, and we're left with b equals 12. So again, when I look at my three numbers that I have, 5, the 12, and the 13, those are all positive whole numbers that work with our Pythagorean theorem. So this is going to be a yes. For part B, it says which value of x, where x is less than 65, will make a Pythagorean triple. So we know that 65 is going to be the biggest, so this is going to be our hypotenuse or our c value. So I can do x squared plus 63 squared equals our Pythagorean, or hypotenuse, 65 squared. We'll grab our Desmos calculator here and figure out what 63 squared is. That's 3969 equals 65 squared. 4225. And then from there, subtract to get the x by itself. We're left with x squared equals, we subtract those two numbers, minus, we get 256. And then we're just going to square root. So the square root of 256 is actually going to be a pretty nice number. So square root of 256 is going to be 16. So we get x equals 16 as our answer. And it does form a Pythagorean triple since that's a whole number and the rest are whole numbers as well.